Okay, let's look at this problem called longest repeating character replacement. You are given a string as and an integer k. You can choose any character of the string and change it to any uppercase English character. You can perform this operation at most k times. Return the length of the longest substring containing the same letter you can get after performing the above operations. Okay, so essentially we are given a string and we are given a k, and k is the number of replacements that we do. And after those many replacements, we have to find the longest substring which has only same character. So in this example, AB, we could replace both of the A's to B or both of the B's to A, and we'll have either all four A's or all four B's. In this example, k equals to 1, that means we can at max replace one character. So let's look at this. So AA is good. This B is becoming problem. Maybe we change B to A. Then we'll have this 4 length string AAA, which only a single character. You can also look at this substring BA, and here if you replace A with B, we will get all B's. And that is another one, and that's why we get the output as 4. So what are we looking at? Let's come to whiteboard. So let's look at the example that was given. A, B, A, B, right? Essentially, what we're trying to do is, and our question was, so looking at any specific substring, I want to check whether that substring meets the condition or not, right? So let's say if I'm looking at this substring AA, it directly meets the condition, right? Same repeating character everywhere, no problem at all. Does AAB meet the condition? How do I find that out? Well, here k equals to 1, so I can replace this B with A, and A is, it will still meet the condition. So in general, what I'm trying to, how do I generalize it? Well, I'm definitely looking at the character that occurs the most number of times in my substring, right? And I'm also looking at the length of the substring. And then I'm saying if the number of characters other than the most occurring character, they should be less than or equal to k, right? So for example, in this case, AAB works because in AAB, A occurs 2 times, B occurs 1 times, and K equals to 1. So we could replace this 1 B occurrence with A and it works. Now if we look at AABA, we have A occurs 3 times, B occurs 1 times, K equals to 1. Again, so A is a maximum occurring, so you can replace this occurrence, one occurrence of B with A, and that will work. Now if you look at this string, AABAB, this one. So this is AABAB. Now here, A occurs 3 times, B occurs 2 times, and K equals to 1. You can only replace 1. So now there is a problem. And how do you figure out there is a problem? You would have wanted, like, what would you want to replace? A with B or B with A? Obviously B with A, right? Whichever is lesser occurring. And there could have been more. Like, that's this. There could have been more. So what's the idea? The idea is you find which guy occurs the maximum number of times. You find the length of the string and you subtract both of them, right? So the length minus max is what your remaining is. What you're saying is the remaining should be less than or equals to k. This is what tells you whether your substring is valid or not. And you have to find the length of this longest such valid substring, right? That's what we are trying to solve for. So what is a valid substring? Well, it's length minus max frequency, right? Which is the character that occurs the most number of times in this substring. Its frequency. It should be less than or equal to k. Essentially, what it means is the remaining chars count. other than the most frequent character, right? This should be less than or equals to k. So that you can replace all of these, uh, as long as they are less than k, you're allowed to replace all of them to the most frequently occurring character. And now with this approach, we can use this sliding window concept and find out, like, start from the initial point, try to increase our window size till the substring is valid. As soon as the substring becomes invalid, so let's say from this point, the substring was valid, all good. And when you take the next guy, now your substring becomes invalid. At that point, you will shrink your window till your substring again becomes valid. And now this is your next substring and you try to increase. And when you do this sliding window concept, you can imagine that at any point in time, you're either increasing your left pointer or your right pointer. So overall, your time complexity of any sliding window concept is just 2 of n. And for every sliding window, you're checking whether a substring is valid using this method. So let's try and build a logic based on this. So we go back to code. And okay, so primarily what we're saying is this thing, valid substring is length of, just call simply, so L minus max count is less than equals to k. That's what we're trying to look for. And we are going to use sliding window, right? So let's do the sliding window. So for sliding window, let's do take the left and right pointers, start with L equals to 0, and we can start a for loop for right. So R equals to 0, less than s dot length, R plus plus. We'll keep increasing R, but within that, we have to count the frequency of every character in the window. For that, what do? We can use maybe an array. Uh, so this string, it says here, it only consists of uppercase English character. That means total 26. So we can call it char count equals to new int of 26, and we'll initialize everything to 0. So that is fine. And finally, we have to maintain something which we will return, which is, we can just call it max, right? And at the end, we have to return this max. So that's fine. So what we are doing is, so we are looking at this, we're increasing our window size. So we are looking at the character at R, which we can call at C equals to, all right, now we increase its count. So char count of C, increase its count, all good. And then what do? Well, we check if our window is valid, right? If this string is valid, if the substring is valid, rather. So as from L to R, if it's valid, and we will need to know whether it's valid or not, we'll need this K, and we need this char count information. And if this is valid, then we can say what? Then we can say whatever its length. So int length equals to R minus L plus 1. Um, So max equals to math.max of max and length of this window, right? So we can just do like this itself. And if it's not valid, then what do? Well, then we'll shrink the window till it becomes valid, right? So shrink from the left rather, right? So we can say while it is not valid as L R K count, what will we keep doing? We'll keep shifting our R. But when we keep shifting our R, that means we have to also update the char counts in the current window. That means if you remove a character, then reduce its count as well. So let's get the character. C at left, character at left is s dot char at L. We want to remove it, so we'll do char count of C at left will reduce its count, and we'll shift A, right? And if you look at it, okay, this is if, this is else, which is all good. To make it slightly better, just readable, like we are doing this is valid here. Essentially, you could just do this condition like beforehand, right? Just this one uh, here maybe, and then if it was already valid, then we wouldn't have required to do this, right? Which is what this is checking. So that is fine. So now outside this while loop, we would be valid only. So just, I mean, what we wrote earlier should also work. We're just making the reducing the lines of code. Essentially, this also means the same as what we were trying to do earlier. So now this is fine. Now let's build this function is valid. So we are saying boolean is valid, and we have this string s, we have the lnr, we have the k, and we also have the count of every character in this window, right? So whether is this window valid or not, how do we check? Well, let's first get the length of the window is r minus l plus 1, that's basic. Let's also get the character which occurs the most number of times, right? So we also want the max count, initialize it to 0. Let's go through each. So int I equals to 0, or rather each, for each count in char count, max count equals to max dot max of count comma count. Now in this window we got the max count, and then what do we do is we validate if the remaining characters. So we get the remaining characters is the length of the window minus the max count. So all of these remaining characters is what we'll try to replace. So they have to be less than or equals to k, because those are the maximum number of operations that are allowed. So that's the logic. If we talk about the time comp, first let's see if it works. Okay, let's fix the errors where while dot. Okay, we define the function as is valid. Okay, let's run again, and let's fix more issues. Line number 32, int max count, char count of, not char count but rather just count. Oh no, max count. Okay, so this is fine. And the two test cases passed. Let's submit as well. And it does gets accepted. Now, talking about the time complexity, so essentially here we are doing the sliding window, which we can clearly know it would be linear only. But within the sliding window, for every window, uh, we're calling this is valid, and is valid is going having this loop, which is going through all the characters, and number of characters are well fixed 26. So essentially it's 26 times n, right? 26 times 2n, so 52n, but overall linear. There's a slight optimization where you don't necessarily need to keep track of the max count. Um so the reason we are like we could potentially just keep track of the max count separately. What I mean by that is, let's say if we do something like uh, a max count is 0 here, and we maintain the max count. So whenever we increment this, we could do max count equals to math.max of max count comma char count of this guy. And now could we use just this max count? And the answer is not. This max count does not correctly represent the maximum, the frequency of the character that occurs the most number of times in the window. The reason is when we are shrinking the window, we are reducing the character counts, and then during that time the max count might not remain the actual max count, right? And we shift the window, so this max count is actually the frequency of a character, which is no longer which no longer may not be in the current window, right? However, and that's where I want to come back to whiteboard. And this is a slightly tricky bit, but essentially what we are saying and what we I want to highlight is this bit. So what we're saying is the length minus max frequency is less than equals to k. This is within the window, right? Within the everything within the window. For any window, this has to be the case for it for the window to be valid. And now if we talk about the length here, so what it says means is length is less than equals to max frequency plus k. K is constant, and our goal is to maximize this length, right? So first time whatever max frequency we got. After that, our length will increase only if the max frequency increases. And that's what I want to harp on. Like, yes, when you're shrinking the window, your potentially your max frequency is reducing, but we don't really care about that. When will max frequency, whenever your max count increases. So what I want to talk about is the bit here. So whenever this max count actually increases, that would only happen when it's accurately representing the max count of a character in the current window, because the char counts are always the counts of characters in the window, and the max count is using either the older max count, which might not match the current window, but if it increases, that means it is taking something from the new something from this char count, and this char count always represents the character count within the window. So if the max count is actually changing, rather if it is increasing, then it would obviously it will always be a new window, or the current window has found a character that occurs more number of times, right? And and so essentially we don't really care about the max frequency decreasing because of shrinking the window. We are only interested in the case our answer will increase or will get the better result only when the max frequency increases. And to optimize that, then basically we can directly use this max count. So here, instead of this char count array, we could potentially pass on this max count, and we could just do int max count. And now we don't need this, we don't need this, we don't need that. And this should also be fine. And they should be slightly more optimal, because now for every window, we're not going through these 26 characters, but just we just use this max count. And so it slightly improves our time complexity here. Obviously, because the function is so small, you could potentially even just use it here itself. So it could be something like so what we're saying is the length of the window, which is r minus l plus 1, length of the window minus the max count. Well, okay, so this while is being run when it is not valid. So it won't be valid if, so this is the case when it is valid. It won't be valid if it is greater than k, right? So we can just use that, remove this and make it even smaller. And this is all your code becomes. Okay, submit. All right.